Good morning, HashiConf. All right, wow, we got a good number of people here. So this is upgrading your provider for Terraform 0.12. My name is Patty Carver. I use he, him pronouns. I am a senior software engineer at HashiCorp. And you may recognize me from GitHub or Twitter. I go by @PattyCarver on both. And if you're going to live tweet this talk, please by all means tag me. I love having like the little red dot when I get off stage. And please do remember that our conference hashtag is #HashiConf. So today we're going to have some fun, and you know we're going to have some fun because I'm starting this talk off with disclaimers. Nothing says good time like disclaimers right out of the gate. So first disclaimer, this is a provider development talk. If you're here in this room and you don't know what provider schema is, first of all, you're valid. You're a developer. Everything's cool. I don't think less of you. But some things might go over your head. If you're expecting me to talk a lot about HCL today, that's probably not going to happen. Alvin does have a talk, my coworker, at 3:05 in our hallway track, and he's going to be talking through that. So you should definitely check that out if that's something you're interested in. And also, I'm sorry, I'm going to pull a little bit of a Jedi mind trick on you here. I'm just absolutely awful at writing abstracts. So this might not be the talk you think you're going to get. When I was writing the abstract, I was like, oh, this is going to be great. We're going to talk, like, I'm going to like take a provider and walk everyone through how you go about upgrading that provider for 0.12 support. And it turns out that's actually not super useful. So I decided not to do that. Instead, we're going to be talking a little bit, so if that is the talk you're looking for, this is like the abridged version of it. You want to make sure your tests pass and that you have tests. You want to upgrade to use Go modules. That's not strictly required, but just it's a good idea. Just do that, please. You're going to go get github.com/hashicorp/terraform at v0.12.8. You're going to run your tests, and you're going to fix the test failures that come up, because there may be some. And then you're going to run the tests again, and you're going to kind of keep cycling between those last two steps as many times as necessary. And that's kind of what I want to talk about today. I want to talk about those last two steps, why they may be necessary, and why you may have to cycle between them. So today we're talking about context. Today we're talking about, like, you know, why are tests going to break? Why did 0.12 happen in the first place? What's going on? But if that's not your cup of tea, if these disclaimers are like, you know, Patty, I'm not super here for that, that's totally cool. We've got 3 other great talks going on right now. These fine people are doing a great job. Please feel free, sneak out the back, go see them. I won't be hurt. It's totally cool. Get your money's worth. So that's the end of our disclaimers. After this point, you're all stuck with me. I assume that you want to be here. So as I said, my name is Patty Carver. I work for the Terraform ecosystem team. We maintain the providers that HashiCorp has a maintenance interest in, which basically means the things that we pay people to maintain. That's not all of our providers. That's just some of them. It's a complicated and weird thing on how we figure out which ones those are. Don't really have time to go into that today, so I'm not going to. Specifically, I work on the Google Cloud Platform provider. I'm not the only person working on the Google Cloud Platform provider. I also have a teammate. She's pretty great. So she works on it with me. She's my teammate at HashiCorp. She's also on the ecosystem team. But of course, HashiCorp actually co-maintains the Google Cloud Platform provider with Google. We have a team of engineers working at Google on the Google Cloud Platform provider. And they're all pretty great. They're my friends. They're awesome. And they have a manager. And his GitHub profile is Batman riding a unicorn. And what was I going to do? Not use that? So there he is. But of course, I mentioned I'm on the Terraform ecosystem team. And that's not just me and Megan, my coworker. That's a bunch of people, because we have multiple providers, and we need people to maintain all of them. So there's my Terraform ecosystem team in all of their glory. And that's quite a few people. At this point, we probably should get some managers involved to make sure that, you know, we're building the right things, that we're working together, and that we're working cohesively with the org at large. So we got product managers and engineering managers to help us do all of that. You're like, okay, great. Patty couldn't possibly put more pictures on the screen. My friends, are you in for a surprise? Because we're not the only team at HashiCorp that's working on Terraform, or even on Terraform open source. There's, of course, the core team as well. The core team does things like maintaining our CLI, maintaining our protocol, and otherwise kind of taking care of Terraform as a whole. And of course, there's our enablement team. And our enablement team does things that make our lives easier. You should really like our enablement teams. They're really great. They do things like maintaining the GitHub HashiBot. They take care of our provider SDK. And they write a lot of the documentation on how to develop a provider. They're really like a force multiplier on provider developers in general, and like they're fantastic. I can't say enough nice things about them. And again, we're getting to a lot of people here, and I haven't mentioned the word manager recently. So to kind of keep all of these Terraform open source working cohesively and building the right things, we have a design director, a product director, an engineering director, and a technical program manager who not only manage Terraform open source, but also Terraform Enterprise. And I'm not going to talk about Terraform Enterprise because our scope is ballooning rapidly, and I just don't have time to explain all of our org chart today. But I'm trying to keep our scope limited here. And of course, finally, HashiCorp and our partners aren't the only people building Terraform. Terraform's an open source project, and so we have open source contributors. In fact, we have over 4,700 open source contributors to Terraform and its providers as of like last week, I think, which is kind of a large number. And I want to talk about that a little bit. Oh, I'm sorry. First of all, if anyone in this room is represented on this slide, either as like an Octocat or as a picture, could you just raise your hand, stand up, acknowledge yourself as you're comfortable or able to? Can we just give these people a round of applause? They do great work. You all are awesome. So before I got ahead of myself, I want to talk about that number. I want to talk about the 4,750-ish people I just put on that screen. Because it's easy to be like, yeah, 4,750 people. I've got like 5 million users. This is whatever. That's just how software works. But I want to think about that because that's really the crux of what I'm talking about today. There are about 1,600 people at HashiConf. This is the largest HashiConf we've ever held. And there are about 1,600 of us here. If each and every person at HashiConf this year brought 2 friends with them, that is roughly the number of people that would be contributing to Terraform over the last 5 years. Washington State requires, like where we're giving this talk right now, Washington State requires 1,500 inhabitants to incorporate a city. It's not important why I know that. Let's just accept that I do and move on. And now, I'm not implying anything, but like we could take all of our Terraform contributors and not form 1 city in Washington State, but actually 3 of them. And really, I'm really not trying to suggest anything, but Init Washington, Plan Washington, and Apply Washington do have a nice ring to them. And finally, this is my dog. And I'm sure you're all wondering, Patty, where are you going with this? This is an abrupt departure. But this is my dog. I feel that's very important. If all of our Terraform contributors gave my dog a pet, she would get roughly 4,750 pets, which is almost 10% of the pets that she believes she deserves. That is the best description, and I'm not gonna lie, I'm a little bit concerned about our priorities that we were building infrastructure automation when we could be petting my dog and giving her the pets she deserves. So my point here is that a lot of people work on Terraform, right? That's a whole lot of people. I spent a lot of minutes just talking about how many people work on Terraform. And that's a good thing, because Terraform's really only as useful as its providers. And I don't mean to knock the work of the core or the enablement teams or the other things that go into making Terraform great, because they're necessary and make Terraform wonderful as well. But at the end of the day, what a user sees, what a user interacts with, the part that's moving that does what the user wants it to is the provider. It's the one interacting with the API. And over time, the number of providers that Terraform has had has increased rapidly. We have almost 1,200 providers that are open source and available on GitHub today. That does not include providers that are developed internally at companies and never released to the public. And that is a startling growth over the last 5 years. And Terraform has a people problem. I hate classifying it as a problem, but it is a problem. Because with all those people and all those disparate projects, how do we keep everyone moving in the same direction? How do we cook with that many cooks in the kitchen? How do we alter the recipe to make sure that we're making the dish we intend to? As we learn more things, as we taste the dish, how do we adjust course? I'm going to abuse that metaphor a little bit further, because we've adjusted our recipe quite a bit in the last 5 years. These are my top 10 favorite moments in the last 5 years of times that we've changed provider development. I'm not going to go through them all today because we don't have time, and they're really just the tip of the iceberg. But we've kind of evolved how we think about providers and how we develop providers a lot in the last 5 years. And I have a secret to tell you. And before I tell you my secret, I need you all to promise to be cool. This is a safe space. Everyone just don't panic. My secret is Terraform works on accident. And I don't mean that Terraform apply works on accident, that like you're gonna run it on your production and it's gonna fail at runtime. We work very hard to make sure that doesn't happen. We work very hard to make sure Terraform is reliable. But the way that Terraform works, the way that we're able to tell what a provider is able to do or not is an accident sometimes. And that's because Terraform's implementation is its contract. When you are a provider developer, and you try something out and it works and you ship it, at that point we feel responsible for it and we feel like we need to keep it working. So a lot of things that people end up depending on are not some abstraction above our implementation, they're actually relying directly on the implementation details. And this is probably fine as we've rewritten basically our entire implementation over the last year. Nothing possibly can come of this that would make us feel sad and regret. Because we definitely do not have any spacebar heating moments. No, sir, none at all. But like, why is it like this? That's something I've been thinking a lot about is why is my life like this? So I want to talk about that today. Terraform's emergent. Terraform, we didn't know when Terraform was started, all of the things people would use Terraform for. We didn't know all the things that it could do and what people expected of it. And we didn't know the entire problem domain, just like any engineering project. And over time, we had to deal with that emergent behavior. We had to deal with learning about new things about our problem space and figuring out the solution for it. And so over time, we allowed the flexibility to go down and the abstraction layer to go up. And that's kind of the ideal, right? Is that over time, you kind of lock in what the program is for, what it does, and how it works. And you take away some of the flexibility to solve other problems by adding abstractions that let you kind of keep those details hidden. But because we're so concerned with backwards compatibility, we didn't necessarily take away all of the hooks into them. And so that's kind of what Terraform 0.12 was, a little bit of cleaning house on technical debt and getting back to working with abstractions and taking away some of the flexibility. So a lot of what you're going to encounter as you upgrade your provider to 0.12 is that things that you were relying on, things that required some flexibility on Terraform's part, will no longer work. And I want to talk a little bit about what those are today. I'll give you some examples and some insight into what to look out for, what to make sure you've thoroughly tested, and where you might find some sharp corners. Because Terraform is like an ogre, or a cake, or a parfait, or an onion. It's got some layers. These are some of Terraform's layers, just some of them. We have HCL, which is our configuration language, which has a type system. We have HIL, which is, if you've ever used like the $ curly brackets, that's HIL. And it's got its own type system. And also everyone's like, oh yeah, this is a first class part of Terraform, but it's really not. If you ever notice that you've got to smuggle it inside like the double quotes, that's because to HCL, that's actually just a string. And then Terraform parses it as a string. It's like, ah, yes, I understand this is HIL, and then further parses it from there, which leads to some weird stuff. There's helper schema, which is how providers kind of define their types, and so it has its own type system. There's state, which represents types in a different way than the other three. There's the provider RPC, which is how provider plugins communicate with the Terraform core library. And of course, it has its own representation of how types are. We've added things like diff customization and remote backends, which kind of interact in strange ways with some of our assumptions. There are complex types to be considered here in how we've implemented them. And we've got validation. And so I say graphs here, like with a parentheses S. It originally said the graph, and then like I showed it to the core team, and everyone laughed at me, and they're like, yeah, sure, Patty, there's just the one graph. And it's like, please don't tell me that. Let me exist in my world where things are nice and simple, and there is just one graph. Apparently, there's not just one graph. Apparently, there are multiple graphs. So for correctness, graphs. Today, we're not talking about the multiple graphs, so you may all stay in my nice, safe world of simplicity where there is only one graph. It's fine. So my point here is there's a lot of type systems. I think I listed off like 4 or 5 different representations of types there. And so I want to talk about some of them really quick. Let's talk about flat map. If you don't know what flat map is, that's okay. We're about to talk about what flat map is. Have you ever opened up a terraform.tf state file? It's a big JSON file. Looks like this. Inside it, you'll notice something like this a lot. And that's a flat map representation. And what it is we're taking complex types and we're mapping it down to map string string. Because all of Terraform state is stored in 0.11 and before as a map of string to string, no matter what it is. And you're like, wait a minute, Patty, how does it do that? You've got complex types. You've got abstract, or you've got scalar types that are not strings. And well, we just coerce them all to strings. It's probably fine. So how we coerce things down, or how we coerce complex types down into string, or into a map string string, is we use things like this. So this is telling me that I've got a list or a set. You know it's a list or a set because it's got the dot number at the end of it. And it's got one item in it because the value of it is 1. That one item is a set. You can tell it's a set because it's got this long number in there, which is really just a hash of the values of the set. You used to have to calculate this like manually in the provider for each and every resource. We did away with that like 2 or 3 years ago at this point. Yeah, you used to have to write a function that would tell what this number was. It was a good time. And within that set, we've got a block that actually contains a map. And you can tell it's a map because it's got that % sign at the end. And the map has one item because the value is set to 1. And it's got a key in there, and the key is GCE project, and the value of that is my project. And so we're using this dot-separated syntax to kind of create a complex type and a map of string to string. You can see it when interpolating. In this case, we're interpolating a resource, then the name of the resource, and the field of the network interface. And then the network interface is a list, so we're using the first item in that list. And the first item is that list is a block, and that block has an access config type on it, and that access config is a list, so we're using the first item in that, and that's a block, so that has a NAT IP field in it, and that's what we're ultimately selecting. And so that's a flat map string. And so we run into a problem. We run into a problem with maps. Because if you had this interpolation, Terraform's not sure whether that's the key, and the value is, it's a map with a key of bar, and the value of that map, or of bar is a map with a key of baz, or if it's a map with a key of bar.baz. Because fun thing about keys is that fun things about maps is that their keys are strings, and strings can have periods in them. So Terraform's not really quite sure which one that is. And you're like, wait a minute, Patty, what do you mean it doesn't know what type it is? Terraform should know about my schema, but Terraform doesn't know about your schema. And you're like, that's not right. I told Terraform about my schema. Like I wrote it into my provider code. So let's talk about how Terraform works for really quick. Really high level. Core team, please don't yell at me. Very high level, how Terraform works is it calculates a diff. And the config and state gets parsed, the graph is built, and the diff is calculated, and that all happens in the Terraform core binary. And then it sends all of that over to the provider, who then makes the API calls to turn that into reality. And finally, the provider sends the new state back to Terraform core, which then saves that and persists it. And we have a problem there. Terraform doesn't know about your schema because your provider knows about your schema, and it's not the one making the graph, and it's not the one doing your diffing. So at interpolation time, Terraform doesn't know what your schema is. Well, how do we fix this? Well, first step is we standardize our type system, so we're not working with like 5 different type systems, because that's just confusing. And the second thing we do is, at the very beginning, Terraform says, hey, providers, what is your schema? And the providers say, oh, my schema is this. And then when Terraform is parsing all of its config and doing all its interpolation, it actually knows what your schema is. And that's one of the major things we introduced in 0.12 that like we didn't talk about at all, but like it's one of the major reasons behind 0.12 is to fix our protocol to allow for this. Unfortunately, fixing this breaks things. As I said, we have some spacebar heating moments where users were relying on implementation details and relying on the type flexibility of Terraform not knowing what our types were. So one of the first things that breaks is that what you set in state actually matters. And I know people are like, of course what you set in state matters. Like, that's why I set things in state. I don't just set random data there. But there's actually rules to what you can set in state. And Terraform 0.11 didn't have enough information to enforce them properly, but Terraform 0.12 does. So you're going to be subject to these new rules now, and you can run afoul of them. I know this because I definitely did. So if a value is known in the configure of the state, only the values from the configure state are valid to set. So for example, that's like a high level. The actual protocol's text for this is any attribute that was not null in the configuration must either preserve the exact configuration value or return the corresponding attribute value from the prior state. And I know those are both very abstract, so we're gonna talk through an example which may or may not be the exact thing that I did that made me realize this. So Google has, I work on the Google Cloud Platform provider, so this is my Google Cloud Platform example. We've got, it's got these things called self-links, and these are URLs, and there are multiple versions of them that are all semantically equivalent. I've got 5 different versions up on screen right now, and these are all basically the same element. They point to the same thing. Terraform should consider them equivalent. And so our issue is we decided at the provider level that we were going to be liberal about what we accept and conservative about what we set. And that helped us allow users to have flexibility, but it also gave us the ability to have predictability and what was going to be input when you interpolated. So we accept any of these 5 things, but we always, 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 always set the top one in state. That's always what's going to be in state, because that's the easiest one for us to get all the information we need out of. So our problem is when you have something like this, where you're creating, this is like, please don't try and run this in Terraform, you'll get errors. But this is a very abridged version. You have a compute instance, it's got a network interface, and you're specifying a network, like a specific network. And then you're trying to interpolate that network elsewhere. And what Terraform is going to do is when you try and create this, it's going to say, okay, and it's going to run a plan. And the plan is going to assume that the network is going to be default when it's interpolated, because that's what's in the config, and there's nothing in the state. So the only thing Terraform has to build that plan with is the default. And it's like, great, I've got a value for this. I know what it's going to be. This is going to be default. But then we go ahead and apply it. It creates the instance, and what we set in state is the full URL of it. And the problem with that is that the full URL of it is not, in fact, a default. And Terraform does not like that. You can't stray from the plan. You must keep to the plan. It's very much like me on vacation. So that's why you've got to be careful. You got to make sure that what you set into your state follows these rules. But there's also schema migration. Schema migrations have new rules because in previous versions, 0.11 and before, schema migrations, when you basically change the layout or the format of a resource, you change what fields are available or the types of them, we gave you this way to migrate your schema to use the new layout and the new format so that you didn't lose any data. And the way we did this was by giving you that map string of state and said, hey, fix this and give it back to us when you're done. And that was fine, because you could just mutate this map string and make it look like what you wanted it to and set it back in state, and that was cool. Unfortunately, now that it's typed, we can't do that anymore. You actually need to be able to parse the state to each and every representation of the schema that you want to migrate between. So you need to keep all of those different versions of your schema around. Because again, we need those types because we have type information, so we need to unmarshal it to the right thing. And you need to actually convert between types, not just map string anymore. And finally, the last thing I want to talk about today is that types are suddenly inflexible. You used to be able to take advantage of Terraform's type system in some really bizarre and unexpected ways. And people did, because they wanted to offer a good user experience for their users. They wanted to create the user experience that their users came to expect, and we wanted to support that. So types suddenly became inflexible, and this was one of the biggest problems. This caused on its own like a couple-month delay in Terraform 0.12 because we ran into this and had to figure out a fix for it. I want to talk about optional and computed blocks, and everyone on the ecosystem team and core team is sitting there like, oh God, because this was a major issue that we ran into. And I really want to stress the importance of looking for this in your code and testing for it, because we had exactly one test failure across the main 3 providers that the ecosystem team manages. That was and a test failed, and a partner noticed it. And if they hadn't, we would have shipped Terraform 0.12 and broken all 3 of our main 3 providers. So this is definitely a subtle and insidious bug that usually doesn't get covered in test cases, and you want to make sure that you're testing for this. So when an API has an optional default value, so it's like, hey, if you don't set anything, I'm going to specify a value for you. I've got an API default for you. There are really 4 users' intents that we want to kind of capture. First is I want to set it to a specific value. Second is whatever is set is fine. I don't actually care about this value at all. The third is that I don't want it set to anything. I want it set to an empty string or an empty list, 0, something like that. And the fourth is I want it set to whatever the API's default is. I want to, even if I changed it to something before, I want to reset it back to the API default. Capturing that in Terraform, this is how we traditionally did it. And usually that's fine with like strings and scalar types because we overload the empty value to be either empty value or whatever the API default is, as is appropriate for that specific resource. Blocks presented an issue for us. So in my imaginary resource here, there's a disk block, and it's got an image. And the disk block is optional. And if you don't specify disk, the API is going to pick a default one for you. So the issue here is we go ahead, we create the resource, and we specify a disk. And afterwards, we're like, you know what? I don't actually want any disks at all. Or I'd like to go back to the API default. And so normally, you would just say, OK, so remove the disk, right? That's going to get rid of our disk. The problem is because this is set from an API value, it has to be computed. Because it's computed, if you remove it from your config entirely and something is set in state, Terraform will say this is fine. There's no diff. You said whatever was in state is fine. So like, there's no issue here. So this doesn't actually work. This is going to say there's no diff, nothing to apply, everything's cool. And your disk is going to stay attached to your resource. So how we worked around this is we abused the type system. Because we said, OK, blocks are implemented internally as a list. Like you access a list, and that's how you get access to the block. So we're going to abuse this fact, and we're going to set it to an empty list. And that'll be like, aha. And that successfully tricked Terraform's type system into being like, oh, there's a diff here, remove the disk. And we're like, hooray, problem solved. Until 0.12, when the problem was no longer solved. Because here's the fun thing, is a block is not an attribute, apparently. In 0.11, there was no real concept of a block and attribute. There was no type for them. A block was just a list of complex objects. In 0.12, a block is a type distinct from an attribute. If it has an equal sign, it's an attribute. If it does not, it's a block. And like, you can't change between the two of those. You get to use one. And a block is either present or not present. It has no set to explicitly not present like option for it. So let's recap. We talked about a lot here really quickly, so I want to take a moment, slow down. Let's recap, cover what we talked about. Getting started when upgrading your provider. You want to make sure you have tests. I really cannot stress like enough how much you want to have tests, even if you're not going to upgrade to 0.12. If you don't have tests today, you should go make some tests. They're really nice to have. You want to run your tests, make sure that either they're passing or you understand their failures. I want to say that, I'd like to say you need to make sure they're passing, but I don't think I've seen all of our tests pass in quite some time because we create a whole lot of resources and APIs sometimes don't always manage to do that reliably. If you're not on Go modules already, you want to upgrade to that. Again, that's technically not entirely necessary. But you want to do it. It's a good idea. Please do it. It's fine. I promise everything's OK. And finally, you want to get upgraded to the latest 0.11 SDK. So go to the last 0.11 release and go ahead and upgrade your provider to that. Make sure everything works. And so that you know what's a 0.12 breaking change and like what's just weirdness between Terraform versions. So that's a good way to get started. It's a good way to prep before you even change anything, before you get any 0.12 features. There are some sharp corners you want to take advantage, or you want to watch out for. When you're setting things in state on create, you want to be careful about what you're setting in state because that's when you're going to get into the problem where you're straying from the plan. And you also, if you're doing creative things when setting things in state in general, you just want to be a little bit wary of that. Generally, if you're setting something in state on create, technically what you're supposed to be setting in state on create is exactly what's in the config. That's, in theory, the thing that's supposed to be set there. And doing anything else may lead to some hard to find and hard to debug. Plan is different from apply errors. And if you're taking advantage of ambiguity in the type system, you're gonna have a bad time. And I know that's a super hard one to find because you don't think of it as taking advantage of the type system. You think of it as just doing the thing that we told you to do. But unfortunately, that is something that we're kind of tightening down now. And finally, how to stay aligned. How to make sure that in the future you're not digging through your code base trying to find these sharp edges, trying to figure out what's going on. There's really no shortcut for it except to kind of familiarize yourself with how Terraform works and the rules it follows. And I know that's super difficult and not always the easiest thing to find. There is a docs folder in the HashiCorp Terraform repo that does have a lot of information about the protocol, has a lot of information about how Terraform thinks about resource life cycles, and generally how to think about Terraform like the core team does, which is going to help you stay aligned and make sure that your provider is using Terraform in the way that Terraform expects to be used, which is something that we will kind of make sure we explicitly don't break on you in the future. And the good news is, once you've done all of this, there's actually a lot of good stuff to look forward to. And I have not actually run these by the core enablement teams, or more importantly, their product managers yet. So let's maybe not take these as promises, but suggestions of things that might happen in the future. We are working on a new SDK. I don't know when it'll land. I don't know what's going to be in it. No, I don't think there's any consensus on that yet. But we are eventually going to get a new SDK that takes advantage of some of the new features that 0.12 has to offer. Things like support for no values might make it in. I think we have at least 3 different ways right now of getting a value out of Terraform's config or state and trying to figure out whether it's set or not, and none of them actually work reliably all of the time. Some of them work sort of reliably most of the time, but also break at some random weird points. And that's because, again, everything's turning into a map string string. And fun fact is an empty string and a null end up both being the empty string in state, and weirdly you can't tell the difference between those two anymore. Warnings. You actually have the ability to output warnings to users in the Terraform protocol, and it's just not exposed yet in the SDK. So things like, oh, this API doesn't implement a delete method, but we let delete, or your Terraform destroy continue so that we didn't throw errors that you can't fix in your face. But you need to know that your infrastructure is actually still there. Is a common one that I've had where I just kind of put it in the debug log and put it in the documentation and hope for the best. But we'll actually be able to surface those warnings to users now. So that's super exciting and something I'm looking forward to. So that's everything I had to talk about today. I know I kind of touched on a lot of topics there. My hope is that I kind of identified some of the hard edges, some of the pointy bits of Terraform that you want to make sure you're looking out for, that your tests are covering, and make sure that, as you're going to upgrade your provider, you don't release something and only to find out that something you were expecting to work broke when your users file bug reports on it. If you're looking for more information on your HCL, or if you just want to go to a fantastic talk, Alvin's doing a hallway talk at 3:05, and I definitely encourage everyone to go check it out and really understand the benefit that the users will get by you doing all of this work for upgrading to Terraform 0.12. But that's what I've got for you today. Thank you so much for your time. I really appreciate it, and I hope you enjoyed the rest of your conference. Thank you.